In this video, we're going to go over partial fractions of distinct linear factors. Partial fractions mean we have to write their expression as a sum of fractions with simpler denominator. So first, we're going to factor denominator and set this equal to a over one of the factors, b over the other factor, and c over the remaining factor. You can switch it around. You can write it as a over x plus 2 or a over x minus 2 and so on. So that doesn't really matter. And now I'm going to multiply both sides by the least common denominator, which is x plus 1 times x plus 2 times x minus 2. My left-hand side, we ended up having just negative 24. When I multiply with a over x plus 1, we have a times x plus 2, x minus 2. When I multiply with b over x plus 2, we have b times x plus 1, x minus 2. Lastly, we have c times x plus 1 times x plus 2. So now I'm going to let x equal negative 1, so I can get rid of the b and c term because they equal 0, and I can solve for a. Then we have negative 3a, and divide both sides by negative 3, then a equals 8. So now I'm going to let x equal negative 2. Then a term and c term goes away, and I can solve for b. So we have negative 2 plus 1, negative 2 minus 2. So we have negative 1 times negative 4, which is positive 4. Divide both sides by positive 4. Then b equals negative 6. Lastly, I'm going to let x equal 2 because a term and b term goes away, and we can solve for c. That is 3 times 4, which is 12. And when I divide both sides by 12, then we get c equal negative 2. So now what we are going to do is we're going to replace a, b, c with the values we found. So it will be 8 over x plus 1 plus negative 6 over x plus 2 plus negative 2 over x minus 2. And this will be our final answer.